Hello friends, welcome back to your UPSC. So today in climatology we will be doing another interesting topic, that is humidity and precipitation. So let's get started. Humidity and precipitation. So this lecture will be having two parts. Today we will cover humidity and tomorrow we will be covering precipitation. So let's start with humidity. What exactly is humidity? Humidity refers to the content of water vapor present in air at a particular time and place. Okay, so like in Jaipur, at this point of time, the amount of water vapor present in the air is known as its humidity. Okay, now water vapor represents 2% of the total composition of atmosphere. Okay, so they are about 2%. There is about 2% of water vapor present in our atmosphere, but the this percentage it varies spatially and temporally, and it ranges from 0 to 5%. So according to temperature and area, the amount of water vapor it varies, and its range is from 0 to 5%. Okay, now there are few terms related to this topic. First is evaporation. Evaporation, as we simply know, it is transformation of liquid into gaseous form, that is water into water vapor. And condensation is vapor transforming or converting again into liquid or solid form. Now, what is latent heat? See, let's take an example. This is a water. This is water. Okay. Now it is heated up. And because of heating, it gets energy. Its molecules get energy and they convert into water vapor. Okay. And now these water vapor, the energy is not lost. Okay. It is contained in this water vapors. So it is the hidden energy which is present in the water vapor, and this hidden energy is known as latent heat. Okay, and when the energy is released after condensation, okay, so as we know that, and by the law of conservation of energy, that energy is never lost. It always transforms from one type into another. Okay, so when the latent heat it is released, when the water vapor they condenses and they cool down. Okay, so when they cool down, they release their hidden energy. This is known as latent heat of condensation. Okay, now there are some terms related to humidity, and the atmospheric humidity we can say is expressed in number of ways, that is absolute humidity, specific humidity, relative humidity, etc., etc. So we will learn about these terms. So the first term is humidity capacity. It is also known as moisture retaining capacity. It refers to the capacity of air at certain volume and at certain temperature to retain maximum amount of moisture content. Okay? See, let's take an example of a glass. So this glass has a capacity that it can contain water up to 50 milliliters. Okay, so this 50 ml is its capacity. In the same way, we have air. So the air at particular volume, okay, at certain volume and at certain temperature, that means volume is not changing and temperature is not changing, everything is constant. So at that time, the amount of water vapor that the air can contain, okay, or the maximum amount of moisture that the air can contain, is known as its humidity capacity. Now what is saturated air? Saturated air means the air is having the moisture, okay, it is having the moisture that is equal to its humidity capacity. That means the humidity capacity, let the humidity capacity of the air be x. So x amount of water vapors are present in the air at that particular time. Okay, so at that time this air will be known as saturated air. Okay, now let's move on to next term, that is absolute humidity. Now what is absolute humidity? Absolute humidity means total weight of moisture content per volume of air at definite temperature. Okay, so let's take volume of air, it's x, okay, and the total weight of the moisture it is containing, let's say it is containing 1 mg. Okay, we have 10 gram of air which is containing 1 mg, 1 milligram of water vapor or moisture content at a definite temperature. So at this temperature it is containing this amount of moisture. This is known as absolute humidity. Okay, next we have specific humidity. Specific humidity simply means the mass of water vapor in gram contained in a kilogram of air. So we have a kilogram of air and the mass of water vapor in grams, it represents the actual quantity of moisture present in a definite air. So at present the amount of moisture this 1 kilogram air is having or is containing is known as its specific humidity. Okay, here we have another term, that is vapor pressure. Vapor pressure means a partial pressure exerted by water vapor in the air and is independent of other gases. Let's take for example, it is a closed jar. Okay, so here we have water vapors. So the amount of pressure they are exerting is known as vapor pressure. For example, this is an example. So here what it is, a partial pressure that is exerted by water vapor. So the water vapor along with other gases, it is present in the air. Okay, and the amount of pressure it is exerting in the air is known as vapor pressure. Now next term we have is relative humidity. It is the most important among all these terms. So relative humidity is a ratio of amount of water vapor actually present in the air, okay, having definite volume and temperature to the maximum amount of the moisture that the air can hold. Okay, so what the actual humidity the air is having and what is its humidity capacity, their ratio is known as relative humidity. Okay, so what is the importance of relative humidity? First, relative humidity. First importance is precipitation depends on relative humidity. How precipitation depends on relative humidity? See, if the relative humidity is high, then there is a possibility of precipitation, and if the relative humidity is low, then the conditions may be dry. That is how the relative humidity indicates the precipitation, okay, if the precipitation will occur or not. And the wet and dry conditions are also indicated by high and low relative humidity respectively. So high relative humidity, that means it is wet condition, and if we have low relative humidity, then it means that we have dry conditions. Okay, now condensation and its associated forms. Now what is condensation? As we have studied, condensation simply means the process of changing or converting of water vapor back to its liquid form, and in this process it releases its energy, which is known as latent heat of condensation. Now saturated air is a air having 100% of relative humidity. Okay, not 100% of humidity, it is not possible. Okay, so absolute humidity is equal to humidity capacity, then the air is said to be saturated air. That means absolute humidity is equals to relative humidity. When this condition is followed or this condition prevails, that means the air is saturated. Next we have dew point. Dew point is the temperature at which the air becomes saturated. So at the point where the AH, absolute humidity, becomes equal to relative humidity, and at this point we have saturated air, and when the air is saturated, or at the point where, or at the temperature where the air becomes saturated, is known as dew point. Okay, now cooling of air and adiabatic changes of temperature. So see, we have normal lapse rate. What is normal lapse rate? As the air goes up, okay, its temperature decreases, and the rate of decrease of temperature with the increase in height is about 6.5 degrees Celsius per 1000 meters. Okay, and this rate of decrease of temperature, or this rate, is known as normal lapse rate. Okay, now the change in temperature of air due to ascent or descent, but without addition of or subtraction of heat. This type of change in temperature of air due to contraction and expansion of air is called adiabatic change of temperature. See, what is adiabatic change of temperature exactly means? This is a air mass. Okay, as it is rising, or this is a air mass, as it is descending, we can see there is change in temperature. Okay, but there, the change in temperature here is not because of release or gain of heat. Okay, so it is neither getting any heat or energy, nor it is getting, or nor it is releasing any heat or energy, but the change in temperature is only because the air mass is expanding or it is contracting. So as the air mass expands, its temperature decreases, and as the air mass contracts, its temperature increases. Why the temperature increases or why it decreases? See, this is air. Let it consider here we have air molecules. So these molecules, they are putting some pressure and they are colliding with each other, okay? And because of this collision, heat is being released. So if we expand the area, the rate of collision will be less, hence the energy will released will be less, okay? So due to expansion, the air will be cooling down, and when we will be contracting this air, they will have less space, hence the collision will be more, and because the collision will be more, the energy released will be more, because of which the temperature will increase, okay? So there is increase and decrease of temperature, but this increase and decrease of temperature is due to internal collision, okay? Internal, this is an internal thing. The outer atmosphere is not having any effect on this thing, okay? So this is known as adiabatic change of temperature. Now, adiabatic change of temperature is of two types. First is dry adiabatic change and second is moist adiabatic change or wet adiabatic change. So in dry adiabatic change, what happens is temperature of unsaturated air decreases with increase in height. Okay, so here we have unsaturated air. Okay, and what is its lapse rate? So the temperature at which the temperature decrease of temperature or the rate of decrease of temperature with the increase in height is 10 degrees Celsius per 1000 meters. Okay, and this type of change in temperature of unsaturated air while ascending or descending is called dry adiabatic rate. Okay, therefore if the air descends, its temperature increases at the above mentioned rate. So if the air is descending, its temperature will decrease at this rate, okay? And if it is ascending, it will increase at this rate. Now, the moist adiabatic change or wet adiabatic change. Moist adiabatic change is temperature of ascending air beyond condensation level, okay? So the temperature of ascending air is beyond condensation level and it decreases at the rate of 6 degrees Celsius per 1000 meters. Okay, so it is less than normal lapse rate. So the rate of decrease of temperature of an ascending air beyond the condensation level is lower due to addition of latent heat of condensation of the air. Okay, so see what happens is this is air, it is rising. So when it rises, here it condenses or it reaches its condensing level, and when it condenses, it releases latent heat, and because of the latent heat or because the latent heat is released, the air mass present here will rise up more further, okay? And because of this, the air or decrease of temperature of an ascending air will be beyond the condensation level, okay? So till here the air was decreasing till the range of condensation level, but due to release of latent heat, the rate of decrease of temperature is beyond the condensation level, and this is known as, here in this case happens in wet adiabatic change or dry adiabatic or moist adiabatic change. Okay, now we will look into stability and instability of atmosphere. The stability and instability of atmosphere, it depends on the relationship between normal lapse rate and adiabatic change of temperature. Okay, so first we have stable air. Stable air means sea air. This is a ball. Consider as a ball. It is in a bowl. So this is its stable position. If we move it upwards, it will move upward, but then again it will come back to its position. So when the air it comes back to its position, or it is not moving or not having any vertical movement, that is either it is ascending or either it is descending, that thing or that movement is not taking place, it is known as stable air. While in unstable air it undergoes vertical movement. Okay, so that is stable air and unstable air. Now we will look into what exactly is stability and instability. So stability, as I told you the example of bowl, here what happens is we have dry adiabatic lapse rate which is more than normal lapse rate. So what happens in this is, consider the ground surface temperature as 45 degrees Celsius. Okay, so now the dry adiabatic lapse rate is 10 degrees Celsius per 1000 meter. So when it will reach 1000 meter, here it will become 35 degrees Celsius, while the normal lapse rate is 6.5 degrees Celsius per 1000 meter. So when it will reach 1000 meters, it will be 45 degrees Celsius minus 6.5, that is 38.5 degrees Celsius. Now see, the surrounding air is having the temperature of 38.5 degrees Celsius, which is higher than 35 degrees Celsius. That is the air which has reached here with dry adiabatic lapse rate. So this air will be cooler as compared to these airs, these surrounding air. Okay, and because it is cooler, it would descend. This air would start descending. Okay, and such descending air or such air is known as or is called to be in stable equilibrium. Okay, so it is called to be in stable equilibrium. And if sometimes what happens is normal lapse rate is less than wet adiabatic lapse rate. Okay, so now normal lapse rate is less than wet adiabatic lapse rate even at the condensation point. So when the normal lapse rate is lesser than wet adiabatic lapse rate even at the condensation level. Okay, so consider this as a condensation level. If the normal lapse rate is less than wet adiabatic lapse rate, then what will happen? The air that was moving up will stop moving. Okay, and such air, the air that stopped moving, is known to be absolutely stable air. Okay, and such atmospheric condition is known to be in absolute stability. Okay, now let's head on to instability. So in instability, let us invert this bowl. Okay, so when this bowl is inverted and the ball is placed on the top of this bowl, So in this condition, if we give this ball a little push, okay, then this ball will fall down and it will start moving and it won't come back to its position. That means this ball is unstable. So in the case of atmosphere, the instability occurs when the normal lapse rate is more than dry adiabatic lapse rate. Okay, so the normal lapse rate is more than dry adiabatic lapse rate. Here what will happen? Consider normal lapse rate. If the dry adiabatic lapse rate is 10 degrees Celsius per 1000 meter, consider normal lapse rate to be 12 degrees Celsius per 1000 meter. Okay, so the air moving with dry adiabatic lapse rate, when it will reach the height of 1000 meter, its temperature will be if the ground temperature is 40 degrees Celsius, then the air moving with the rate of dry adiabatic lapse rate, then its temperature will be 30 degrees Celsius at the height of 1000 meter. While the air moving with the speed of with the rate of 12 degrees Celsius per 1000 meter, its temperature will be 28 degrees Celsius. Okay, so the surrounding air will be 28 degrees Celsius while this air mass will be 30 degrees Celsius. So this air mass will continue to rise up. Okay, and this state where the air mass rises up and expands, okay, so when it will expand it will be cool, it will cool down. So this state is known as atmospheric instability. Okay, and in case if we have wet adiabatic lapse rate, that is also less than normal lapse rate. Okay, if the wet adiabatic lapse rate is less than normal lapse rate, the rising air further continue to rise up. Okay, so the rising air will further continue to rise up, and this continued upward movement of air is known as absolute instability. Absolute instability. Okay, and when the ascending part of the air, it reaches such height that its temperature is equal to the temperature of surrounding air. That means if it reaches at the height where it is also 20 degrees Celsius and other are also 20 degrees Celsius. Okay, so the upward movement of the air will stop. Okay, and when such air or at such condition, this air will be known to be at the state of neutral equilibrium. Okay, so this state will be known as the state of neutral equilibrium. Now next we have mechanical instability. So in mechanical instability, what will happen? There is an abnormal condition where we have exceptionally high normal lapse rate. So consider it to be 15 degrees Celsius to 35 degrees Celsius per 1000 meters. Okay, so in such condition what will happen? The upper layer of atmosphere will become exceptionally cold. Why it will become exceptionally cold? See, if we have 40 degrees Celsius here and at the height of 1000 meters, it will be considered to be 30 degrees Celsius, 35 degrees Celsius. So it will be 5 degrees Celsius. So this air is very, very cool as compared to the underlying layer. Okay, So it will be exceptionally cold, and because it is exceptionally cold, it will be denser than the underlying air. Because of which, what will happen? The cool and denser air, okay, it automatically starts descending, okay, and such situation is known as mechanical instability. And this mechanical instability, it will help, or it will be the cause of the formation of tornadoes. Okay. Next we have conditional instability. Conditional instability, in which what happens is, this is a air mass which is forced to rise up. Okay. So initially it is forced to rise up. So it cools at a dry adiabatic collapse rate. So consider the dry adiabatic collapse rate is 10 degrees Celsius per 1000 meters. Whereas the normal lapse rate is 6.5 degrees Celsius per 1000 meters. So after rising at a certain height, it will become saturated, okay, because the air surrounding it will be much warmer, okay. So if it is 30 degrees Celsius, it will be 20 degrees Celsius, while the others will be, okay, I'm so sorry. So while the others will be 23.5 degrees Celsius. So this air is much cooler as compared to the surrounding air. And because it is cooler than the surrounding air, what will happen? It will condense, or it will be saturated. And as it is saturated, the latent heat of condensation will be released. And as the latent heat of condensation is released, so this energy, it helps in rising of the air mass. Okay. So this air mass will rise, and now it rises and it cools at wet adiabatic collapse rate. So now it cools at wet adiabatic collapse rate, that is 5 degrees Celsius per 1000 meters. While normal lapse rate we have is 6.5 degrees Celsius per 1000 meters. Now, consequently, the air here will become warmer. Okay, and then the surrounding air, and hence it will rise upward automatically. So here the air will become warmer and it will rise automatically. This condition is known as conditional instability, okay, where the air was initially forced to move upward, but after it was forced to move upward, it raised automatically due to its own property after condensation point. Okay, so after condensation point, latent heat energy was released, latent heat of condensation was released, which moved it further upwards till wet adiabatic collapse rate. Okay, so this is known as conditional instability. So with this we can complete our humidity portion. The precipitation portion will be completed in our next class. So that was all for today, guys. I hope you enjoyed today's class. Let's meet in our next lecture. Till then, take care and have a nice day.